Unit 3, Part 5. So Unit 3, Section 2 is called Computing Truth Tables, same title as the chapter itself. So now we're getting into actually evaluating formulas. Right? Formulas are our symbolic expressions of sentences. Getting into evaluating their truth values, okay? So we looked a little bit at this at the end of Unit 2, where we have our sentential operators, right? The wedge, the hook, the dot, and so on. These are rules for the construction of sentences, right? The rules allow you to do a lot, but they do require you to do something specific, right? So all of them, except for the tilde, except for the negation, right? So the wedge, the dot, the triple bar, and the hook are all two-place sentential operators. So you have to put a legal formula on the left and a legal formula on the right, and you have another legal formula, right? That's how you make more legal formulas, right? And this is what it is. This is what the form of sentences are. This is the logic. Once again, the validity of an argument is determined by the form, right? It's only an argument, a particular argument is valid only if its form is valid. Its form is valid if and only if that form has no counterexamples, no substitution instances with all true premises and a false conclusion, right? So the form of the sentence the form of any sentence is expressed by the order of the symbols. And at the end of Unit 2, we looked a bit at the brackets and how that tells you about, right, that indicates the structure or form of the sentence. Now, we have first 3 or 4 parts of the lectures on Unit 3. We talked about truth functionality and how truth functionality made truth tables for our operators possible. And it's what allows us, as I mentioned, to calculate the truth value of any formula. Right? We have a truth functional system of logic, which means all of our operators are truth functional operators. So given the truth value of our component sentences, and you will always be given the truth value of your component sentences. So these examples here on page, section 2, so page 42, 43, right, so page 42, A, B, and C are true, X, Y, and Z are false. You're given those truth values, and you're asked to compute the truth values of these formulas, right? So I'm going to do it one way, and then talk about another way you should be reading these things. And as you will see, this is simply a matter, computing these truth tables is simply a matter of applying the knowledge of the truth tables, right? And it's because most of what you'll be doing is applying this knowledge of the truth tables that you really need to understand them in the way I said, right? Know that the dot, a conjunction, okay, it's true when they're both true, when both conjuncts are true, false in all other cases. Okay, I've got a wedge. It is made true when just either one of those wedges are true, or both, right? The truth of one dot, well, if I've got a wedge, if I've got a disjunction, the truth of one disjunct suffices for making that disjunction itself true, right? So I'm going to be putting T's and F's, T's and F's for true and false over, first of all, the atoms, right? The simple sentences, the capital letters, those truth tables I'm given. And then I'm going to compute the truth values of the compound formulas, right? The complex or compound formulas constructed by the sentential operators, for which we're given symbols. Okay, so let me do a computation, and then just how you do it, working as it were from the inside out, or working, assigning truth tables as per the order of the construction of the formula. But then I'll tell you how to look at it sort of from the other way round, asking what the major operator is and so on. But first of all, okay, we're given that A is true, so just do this one first. A is true, Y is false, okay? And X is false, X, Y, Z are false. I say Z because I'm Australian, so get used to it. X, Y, Z and false, so that's false. Y is false, A is true. Okay, so that's the truth values of those components. Now I compute the truth values of the subformulas and eventually get to the truth value of the formula as a whole. Okay, now here, right, this is this is T, this is F. Working up, this conjunction is made of A and Y, right? I've conjoined A and Y. Okay, is the conjunction of A or Y true? Right? Is this is the disjunction A or Y true? Is this disjunction true or false? Well, it's just a matter of applying the truth tables. It's true just in case at least one of them is true. It's only false when both disjuncts are false. Okay, well, A is true, so that's enough. This is true, right? A or Y is true. Okay? So now, looking at the next step in the order of construction, right, what I have is a conditional, right? It's a, learn to speak like this, learn to read these formulas like this. This is a conditional where the antecedent is a disjunction and the consequent is just this atomic formula, right? Now, under what conditions is the hook true? When is it false, right? Under what conditions are conditionals, as these sentences are called, true? These formulas are called the conditionals, right? Well, it's only false when it's T hook F, right? So look what I'm doing. I'm thinking of the table for P hook Q, right? And it's always P hook Q, yeah. Right. True, true, false, false, true, false, true, false. It's true, false, true, true, right? It's only false when the antecedent is true and the consequent is false. It's true in all other cases. But look here, now you need to realize what your P is. Your P, right, this is a conditional, right, and the conditional is always a two-place sentential operator, right? What is the conditional? It's a rule for constructing formulas. You put a formula on the left and you put a formula on the right, voila, you've got another formula. But now you've got to realize that the formula on the left, or the P from the table, is this compound formula, A or Y. Right? That itself is the P. Right? P and Q are sentential variables that take as substitution instances any sentence, simple or complex, and no matter how complex. Right? A lot of what you're doing in logic is learning to see the simple forms in complex formulas. Okay, this will be especially true for the second part of the course, unit 7 to 9, on proofs. Right? So you need to be able to recognize this. This is going to be the second way. Recognize this as a conditional. Right? Asked if this formula is true or false, you're asked whether this conditional is true or false. Because the conditional is the major operator. That's what it is. This is a conditional. Right? So is it true or false? Well, it's false if the antecedent is true, that is, if this is true, and the consequent is false, which happens to be the case. So this is actually false. So the formula as a whole is false, right? But that's, you got to recognize that that's what this is. This is a conditional with the antecedent. It's a conditional with the antecedent is a disjunction, right? So I first have to calculate the truth value of that to know whether that is what the truth value of the final thing is.